and welcome to part 2 of our video series, Rhino.Inside.Revit. In this video I'm going to cover the facade system, the whole damn thing. So sit tight, relax, and let's get started. So this is where we left off last time, and basically we have ourselves a little bit of a slab system and some columns, and that's basically it. And of course we do also have our guiding surface that I can show you right here. Here it is. It's right here, and there it is. Right, so we have our guiding surface. So what we're going to be working on today is we're going to be cladding it with facade elements that, well, honestly can only be made with either Revit's Dynamo plugin or Grasshopper. So of course we're going to be using Grasshopper because it's quite more powerful than Dynamo as it is. So let's get started. First of all, I do have this this shell of a let's get it in here. There we go. I do have this shell that I will be tiling the elements onto. So there are different ways of how you can actually kind of tile the elements. The one that I'm going to be using is going to be called box morph. And what it does, it basically takes any geometry that you draw inside of a box and retargets it, or kind of morphs it into any other twisted box that you might have. So what do we need? Well, first of all, we need some sort of a geometry. And I'm going to just go to my top view here, and I'm just going to draw. Let's just draw a rectangle, or rather 1,000, sorry. Let's draw a rectangle 1 meter by 1 meter, so 1,000 by 1,000 millimeters. A very small one. Let's zoom into it. And honestly, let's stay a little bit inside of Rhino while we're doing this. So I'm initially creating the element that's going to be tiled, and our element is going to have multiple layers like glass, metal framing, we'll figure it out. So right now I'm just going to kind of give it a very basic shape, and then we can detail it later on. So for now, just a rectangle here, and let's hide the sight line so that it's not in the way. And let's actually create a new layer, call it element, just element. Let's just make it something like blue. Like that, change object layer, there we go. Our little rectangle is right here. It's a little bit flimsy. Let's see if, no, that doesn't help. Sure. The line weight is a little bit small, but thin, but it is what it is. And then for this element, I'm just going to give it a little bit of an offset. Let's give it like 0.05. Wait, that is, we're not in meters, we're in millimeters, so let's give it 50 rather than 0.05. Forgot to make sure that we're working in the same layer. But either way, we have two rectangles, one in the other, and I'm now going to make them three-dimensional. So let's say this frame right here, basically we're going to have like a metal frame, and we'll have like a glass panel inside of it. So for the metal frame, let's do planar surface, something like this. And then for the glass inside of it, also a planar surface. That's easy. Now let's extrude the frame upwards by the way, the extrusion is when you select an object, as long as it's a single surface object, you can click on this gumball dot thing on any axis, and it's going to extrude rather than move along that axis. It's just a little bit of a tip right there. So let's extrude it by 0.1. Nope, I lied. Ctrl Z, undo. Let's extrude it by 100 millimeters. I need to get used to working with millimeters rather than meters. And then honestly, the blue color is obnoxious and hard to it's hard to see what the hell I'm doing, so I'm going to disable I'm going to change the color back to black. It's just better, honestly. And then I'm gonna take this surface right here, extrude it up by let's say 20 millimeters, so that it's just a 20 millimeter plate, you know, glazing. And then I'm just gonna move it up by 100 minus 20 is 80, divided by 2 is 40, by 40 millimeters, so that it's centered right in the middle of the panel. And that's it. This is our very basic setup for the panel. Okay, back in here, I want this whole surface, this whole facade surface, to be divided up into smaller boxes. And in each of those boxes, this panel should be placed. And it should twist and turn to fit perfectly inside of the box. How do we do that? Well, first of all, we need boxes on the facade. The panel for now just stays, we have it ready. But for now, let's do the boxes on the facade. Well, here's our surface, right? I need to make boxes on it. We will be using a tool that's called Surface Box. Surface Box, there we go. Like that. Which asks us for three things: surface, domain, and height. So basically, what's the surface, what's the domain of the surface, and within the surface, and what's the height. So our surface is the loft. That's easy. Our domain is what's a little bit more tricky, and I'm not going to overly focus on it in explaining it, but it's basically like the mathematical divisions according to length, from, let's say, in length from 10 millimeters until 100 millimeters, and then in width from 5 millimeters until 20 millimeters on the surface will give you like a small patch. So we somehow need to divide the surface into these kind of domains, into these kind of patches. And I will be using divide domain squared for that. Divide domain squared asks us for three things. The first one is the base domain, which is our same lofted surface. And it can connect directly into the surface domain right here. By the way, if you want this file, every single file that I do, to be able to download it, if you want to be able to download every single file that I make in these tutorials, and you don't want to follow along, but rather just get the files, consider becoming a Patreon supporter. Support the channel and you get the files for free. So that's a thing, link in the video description. But either way, we have divide domain, which spits out our segments, and you can see if you hover your mouse over the output, you can kind of see what kind of segments it gives you. And it also asks you for what's the U count and what's the V count, right? How many, and you can already kind of see it dividing things up because it's 10 by 10. So it asks you how many elements do you want along the X direction, along the Y direction, the U and V direction. So I can for instance say 15 in U direction. Let's hide the slabs so that they're not in the way. Let's actually hide everything except the panels. So as I'm increasing here, you can see it's kind of change. Cool, huh? So I can do, let's say, let's leave it at 10 here, and let's do like 12 in V direction. Maybe not 12, maybe 20. Why not? Something like that. And you can kind of see that it changes this. It's not a uniform size, and the size is actually controlled by what's the gap between the control points of the curves that were used to create the loft of the surface. So those control points, let me try and find them. 1 second. There we go. Like that. you can see that the gaps between the control points actually correspond to, there's a control point there as well, correspond to the length, right, of these segments, or at least they should. I think they should. Anyway, so we have that. Now we have a bunch of boxes. We still haven't added the height of them, so they're very, very thin. Those boxes are actually only 1 millimeter long. And also notice how here it's not curving, right? That the box itself is not curving. The box stays not necessarily flat, but it's rectilinear, right? So these 2 points, these 2 corner points of the surface of the box, sorry, are always going to be connected with a straight line. You will never get a curved line in a box. Same thing applies here, so you might end up needing to have a little bit more resolution to make this work properly. But that's later. For the height, I can say, I don't know, like 800 millimeters, something like that. Initially, you would probably want to use something similar to this, you know, like, because it's like the metal frame. But just to be able to show you how it works, I will use 800 millimeters, and then we can kind of adjust the sliders as we please once we have the whole setup done. So 800. You can see the boxes are doing their thing. Unfortunately, it seems like it's offsetting inwards, not outwards, which sucks, but I can easily do this by fix this by saying that the height of the boxes is negative. And now it's offsetting outwards. So that's easy, an easy fix, right? Let's keep it at a meter, and just to be safe. And let's hide the loft. And now we have a bunch of boxes, right? So that's one thing. Then we have a bunch of boxes for the box morph to work. Remember box morph, right? This is where we will start using it. Box morph asks us for 3 objects, or 3 inputs: base geometry, reference box, as well as the target box. So base geometry is what are you going to be morphing? This panel right here is going to be box morphed. Before I kind of don't want to morph both of these at the same time, like the metal framing and the glass, simply because I want the materials of them to be separate, right? So I want the entities of them to, I want the outputs of the box morph to be separate for the glass and the metal. I could technically do this by grouping them up and grouping them up in Grasshopper and morphing them that way, but I think it's just better to have 2 box morphs, one for glass, and let me just, can I do this? Glass. That looks a little bit weird, but maybe that's gonna work. One for glass and one for frame. Blob. Frame. There we go. And I will reference in as a brep, set1 brep, my glass, like that, connected right here. And also I will reference in the frame as a brep, right click, set1 brep, my frame, plug it in to the geometry to be morphed. My target geometry, I'm skipping over reference box, just give me a second, I'll talk about it in a little bit. I'm skipping over that. Instead, I'm going to be using my target box right here, which is going to be like the targets are all of the boxes onto which the geometry should be morphed. So it's my surface boxes. I just connect them like so. Bam, bam. Now our reference box. So it needs to know from where does it start morphing, right? From what kind of a box will it start morphing? So here I could just draw a box, but I feel like it's easier if we just do domain box a domain box. Let's give it a little bit more breathing room here. Like that. Domain box, and I can specify that X and Y, the size of X and Y, it's going to be whatever the size I used for this box right here, or for this frame right here. So that was 1 meter by 1 meter. 1,000 by 1,000. And then for the Z, I kind of need to decide what's the height from which I start morphing. So in this case, I know that I extruded this by 100 millimeters, so it's not a no-brainer. I just use 100 mil in the Z to create a box right here. And you can kind of see it. It's now overlapping with other geometry, so it's tricky to see, but you know, the green thing right here, not the grid, but the green thing is the box. I should probably hide, doesn't matter, trust me, it's a box. So we have this as our base box, and this is our target box. So I can easily now say that my reference is here. Bam, all of the panels, or the glass panels, have been placed correctly. And then my same base is used for the frame. By the way, you need to use the same base or else things will misalign. Like that. And now the frames are imported. Cool, huh? So now I can, I could start kind of exporting them into Revit, not exporting, but creating nodes for exporting into Revit. But before we do that, we will need to kind of make it a little bit more interesting. If you kind of want to show, well, you already can see it in Revit because we have our shaded preview enabled here. So in every level, there we go. In every level, in every 3D view, in every section, it's going to show you the facade properly. Also, there's a column there. Right. That's one of our columns. So you can kind of investigate how it looks like, even without baking it out. Okay. So we have a very, very basic element here. Let's make it a little bit more interesting before we move on to the next step. And to make it interesting, I will just kind of go in here. Perspective. Let's work in Rhino. Top view, and I'll just delete the whole damn thing, and let's hide everything here, and let's create a new rectangle. So we're creating a new element from scratch, 1,000 by 1,000 millimeters. That should be fine. Then let's do an offset. I do like the 50 millimeter offset, but I think maybe let's be a little bit more elegant. Let's do 25. That might be a little bit too thin. Come on, quick decisions. I can do this. Quick decisions. Is 25 too big? Too small? Let's do 30. Then it's easy to make a decision when you do just 30. And I kind of want to have a pattern that does something like this, maybe. So there's like more framing here. How do we do that? Well, I need the gaps to kind of align. So let's do an offset of 15, but to both sides, like that. So that's 30. Like that, that's 30. Okay. And I don't need those. And then I kind of want a really strong beam going through here. So that should be like double. So 30, offset 30 to both ends, like that. Maybe even more. Give me a second. I'm Daddy's thinking. that is thinking. Okay, scratch that. Scratch that. What if we have 3 layers rather than 2? So it's not just frame and glazing, but it's actually frame, glazing, and then some sort of a overarching panel that has a very strong presence. Maybe that's the way we should do it. So let's go back to our initial little rectangle, and I do like this part from midpoint to midpoint here, from midpoint to midpoint here, and from midpoint to midpoint here. I do like this part, something like this as a panel. But then I kind of want to give it a little bit of a like thickness, so let's do like 40 or even 50 to both ends here. Yes, something like that. And let's do like 50 to both ends here. Something like that. And then the outer frame should be 25 or 30. We're using 30. So that becomes 30. Let's clean this up a bit. Let's use extend right here to extend it. Basically, use any means, any drawing means that you want, but I'm just using extend and trim to just have them cleaned up into one big happy shape. Something like that. And notice that I'm not touching the, or actually I should touch the outer panel. I'm stupid. Extend that completely until it reaches the outer panel, like so. Let's do some more trimming, like so. Yeah, something like that. So this is going to be the main frame, the frame that makes it so that the element is able to hold itself, or the whole facade is holding itself, and everything inside is just going to be like additional framing for the glazing. Yeah, I think that will work. We just need like offset 15 here, here. I'm just gonna create like a small framing that anchors into the big framing for the glazing to sit in, basically. So something like that. I just gave like 15mm offset for all of this. Let's do some more cleanup real quick. Nothing too fancy. So this needs to be like a closed triangle. This is gonna be like a closed pentagon. Something like that. This is gonna be a mirrored version of that closed pentagon. Something like that. And our little closed triangle again. Okay, we finally have all of this done. Now I'm just going to make a planar surface right here. So this is a surface. Let me change to shaded view. A surface. And I'm going to say split. And this surface is going to be split with all of these curves, right? Now I don't need the curves anymore. I should have probably selected the curves beforehand. Is it? How can I do this now? Whatever. I'll keep the curves. We'll clean it up in just a while. For now, we were just kind of keeping them. Now I'm going to take these and I'm going to extrude them up by 20mm. That was not an extrusion. Let's try again. Extrude up by 20. There we go. That was the extrusion. Then take the smaller frames, like these, and extrude them up by 50 millimeters, like that, and take the biggest frame, the H frame, and extrude that one up by probably like 75, right? Yeah, that looks like it would work. So 75 millimeters. I think that's gonna work. We could do even more, but let's not. Or actually, sorry, changed my mind. Let's do 100. That was not 100, that was 1,000. There we go. A really heavy frame. Now I'm going to take only the glass, and I'm going to move the glass panels, and I'm going to move enter the glass panels from their center point to the center point on this vertical edge of the smaller frame, like so that they're kind of centered in their little frames. And that's it. This is like a fancier version of what we were doing before. Since we're kind of keeping all of it clean, or actually I will not be joining them up. I want to show you how you can do it with separate pieces, how you can do the box morph with separate pieces. So we're doing it with separate pieces. For glass, we have the B-rep. If I were to say add to group, or that was a mistake, let's clear values, set multiple B-reps, and let's just select all of the glass plates, enter. You can see that the glass doesn't transfer properly. Like it kind of works here and then stops working there, and like it's a mess. It's a complete mess. So why does that happen? That happens because you have 4 pieces of glass, and basically it just goes 1, 2, 3, 4, and then keeps repeating the piece number 4 for the remainder of all of the elements. You don't want that. You want all 4 of them to be repeated through every single box, right? So for this, these 4 B-reps, we hold the Control key, we disconnect them from the box morph, and we use group to group them up, like that. And then we connect the group, and we wait a bit, and it transforms properly. Yay! Let's see how it looks like in Revit, which doesn't show it to us for some reason. Hello, Revit? Come on. Come on, Revit. Okay, whatever. Revit doesn't want to show it to us. We'll force Revit to show it to us later. Right now, I'm not going to spend time investigating why. Doesn't matter. Doesn't matter that much. So we have our glass. Then let's do the same thing with the frame. B-rep, disconnect, group. B-rep goes into group, group goes into frame. Oh, I think I know why it doesn't show. Because Revit doesn't understand what a group is. We'll need to fix it a little bit, and then it's gonna work. Set multiple B-reps. 1, 2, 3, 4, 5. I think that's all. Wait a little bit. You can see it's a little bit on the heavy side, like the transformation. But it does finally manage to do it, and this is how it looks like. You can see that Revit still doesn't show it, and that's because your box morph spits out groups. So to actually see what's going on, we ungroup the glass plates like that. And now I assume, yeah, they're here. They're inside of Revit. And same thing for, well, they're not inside of Revit, but they're shown in Revit. And same thing for ungroup. For the panels or the framing. Bam. Give it a second. It takes a while to transfer. Okay, let's not look at any of these. Let's take a look at how it looks like in Revit. That looks pretty nice. Pretty dope. but we'll make it even more dope. So for now, this is fine. This is fine. And of course, we will be increasing the resolution later. So now, layer number 3, the most interesting layer of them all. Let's make a box right here, right next to the element. Let's make a box that is like a stick, something like this. Slightly too large for the element itself and all over the place, and let's do 100 mil and move it into the correct position so that it's right here, like so. And we just have like a weird ass box here. I want this box to be on top of every, well, it's not gonna be box later, but for now it's a box, to be on top of every element right here. I want the box to be there, and I want the box to, what do I want it to do? I want it to rotate in a parametric manner, you know, the funky, let's make a funky facade, a funny haha facade. So to do that, we need to do some form of some form of math or relation based math. What's the fastest way for me to teach? Yeah, I know. Let's go for maths, or sorry, vector field, and let's use spin forces. That should be pretty fast. Spin force. I will not be explaining the like every single step, and by the way, this is gonna be heavy because with every node that is placed, it's going to keep updating the preview. So I'm just going to turn it off right now so that it's faster. So I'm not gonna be explaining this too much. Just think of it as creating a mathematical field, and it has a direction associated with every single point in the space of that field, and we're going to take those directions. It's like a magnetic field thing, almost. It asks us for planes, and it asks us for strengths and radii and so on. The planes we can easily get by just taking a circle and drawing a circle like so. Let's make like 1, 2, 3 circles like that. Size doesn't matter, as long as it's a circle it should be fine. Let's reference them in as curves. Set multiple curves, 1, 2, 3 like that. And let us extract planes from them. So we can ask, are these circles planar? Are these circles planar? Is planar. And of course they are. So they give us the plane. And if I rotate the circle now, the plane rotates with them, which is great. This is exactly what we want. And then I can take these planes, not the frames or not planar output, but the planes themselves, and I plug them into the spin force. The strength doesn't matter, the radius does. So for the radius, let's use something pretty aggressive, like 10 meters, 10,000 millimeters. We might need to end up using something even bigger than that. We will see. And then I'm just going to place these guys somewhere around the facade. Again, this is a Revit or Rhino.Inside.Revit tutorial, not a Grasshopper tutorial. For more of these, subscribe to the channel. I will most likely be making quite a few fancy Revit facade tutorials with Rhino.Inside.Revit in mind. But for now, this is good enough. We have something like that. This spits out 3 fields, not 1 but 3 fields. those three fields need to be merged, so I will use merge field. Basically, it means that the three forces don't interact with each other, and after merging the fields, they do. So that is a thing that we've just done. Then we need to, basically we have now a mathematical field, so there's like a bunch of directions like happening, you just don't see them, or kind of movement is happening, you just don't see it. So how do we get the directions? Well, you need to use evaluate field. You need to use the evaluate field node right here, which asks you for a field to evaluate. That's the field that you got, and it asks you for point to evaluate the field at. How the hell do we get points, and what are the points at which we evaluate? Well, for that we kind of need let's say a center point of every panel here. So thankfully we have a bunch of surface boxes here. Let me hide the panel so that they're not in the way. We have a bunch of surface boxes, so I can get the center points of each surface box. How do you get the center point? Two ways actually. First one is simple, the second one is not so simple. I guess we can use the simple one. Yeah. Volume. If you just measure the volume of any volume properties could not be solved. Never mind, we're doing the non-simple version. Evaluate box. Gives you always the center point. That was actually very simple. Because U, V, and W values are always set to 0.5, so it will always give you like halfway in all three directions of the box, which is the center point of each box. You don't need the plane, you need the point. Keep that in mind. So you care about the second output, and that is actually the output that you use to evaluate the field at. All right. Now we have a little bit to work with, a little bit more to work with. Actually, at this point, I can kind of show you. I'm disabling things, hiding things so that they're not in the way. At this point, I can kind of show you the directions of the vectors that we get by evaluating the field by just saying SDL, line SDL. Asking for start point, direction, and length. So our start point might be, the same point from which we are evaluating the field, like that. Our direction is actually the tensor, which is like a vector direction of the field at that point. And the length, let's just give it like 5 meters or so. Ta-da! A bunch of hair, yay! But you can kind of now see what's happening, right? The little circles are spinning the sticks around, and once they're kind of interactive with each other, it becomes a pretty turbulent area of spinny boys. So you can kind of play with this, and then you can make it pretty interesting for yourselves. I'm not going to spend too much time on this because I want to not have a 5-hour long tutorial. So this is basically just line SDL is just to show you that direction. We are not actually going to be using line SDL, so let's delete it. Delete button doesn't work. Let's delete it. There we go. Good. So what are we going to be using? Well, we're going to be using this little stick right here, right? Don't forget the stick. The stick is important. So I'm going to let's think. We kind of need to just a second. So we need our little stick to only be able to rotate around the center point of the element. That is a given. but also it needs to only be able to rotate along the element. It should not be able to rotate this way, like that, right? And unfortunately, the field doesn't care. So if we just inherit the vectors, the elements will start intersecting quite a bit with the facade. So we need to be a little bit more scrappy, a little bit more... we need to figure this thing out a little bit deeper, a little bit more. So I'm going to say, okay, can I... For any center of this box, can I, like these points, can I push these points back onto the underlying surface, the lofted surface that we have here? And let me just create a surface like that, connect the loft. This is our like initial starting guiding surface, right? The main one. So can we connect the loft and use this surface and this point, and can we push these points onto the surface? I think it's pull point. No, it's surface closest point, like that. So points that are pulled and surface that it's being pulled to. What it gives us these UV points, which we can use to evaluate the surface. Bear with me. It's gonna end soon. the pain is gonna end soon. So we evaluate the surface at the given UV coordinates. So initially what we're getting is a bunch of information, right? You can see that we're getting the point again, we're getting the directions, which is very important. We're also getting the normal that we might need to use. Yeah, we will be using, because we'll be rotating around the normal, vector. And what else? U direction, V direction, and frame. So U and V, we will be using that because we have our tensors here that are doing their thing. Let's see. Vector display. This is just for me to show you, so you don't need to follow along. But basically we have our vectors here that are kind of going out from the surface, but they do have like an angle at this given plane, right? So we need to find that angle. And the way we do this is by measuring the angle between two vectors. The first vector that or rather the second vector, is going to be our tensor. The plane in which we measure is going to be the flat plane at this point, right? So it's going to be the frame. And the angle, or goddammit, the A vector is going to be either U or V, and I'm not sure which one. Well, we just guess, I guess. So let's go for V. I'm just gonna plug in V here. If the elements, if the sticks, these guys, rotate in a weird way, then I'll just switch from V to U later on. Okay, we have ourselves a little bit of an angle. That's fine, but we still need the... Well, first of all, we need these guys to be actually transferred there. So let's do... Actually, let me just take all of this. I'm just literally taking this, copy, paste, Control C, Control V, like that. Let me rename this to thick, and the brep, clear values, set one brep. There we go. So here we have, we get a bunch of sticks that are, you know, they're kind of crossing each other. That's fine. We will adjust this later, but they are here. So these sticks, each of them, each single one of them, will need to be rotated. Yeah. So we don't really need to ungroup it just yet, because we can work with them as a group. So the sticks are just the main output is what we're going to be using, and we're going to be using rotate 3D. Rotate 3D. Geometry, of course, we're rotating the sticks. The angle of rotation is going to be our angle that we got by measuring the angle between two vectors. Let me make this bigger. So angle between two vectors. Bam. They are doing something. The problem is that the center point is 0, 0, 0 and the axis is Z. But they are doing something. So the center point. What is the point around which each of the sticks need to rotate? Well, that's the center point of the box, right? Let's find where the hell it is. There it is. This guy right here. Bam. Center point of the box. Or actually, just to keep it clean, I will use this point right here because they're very close to being the same, so like that. And the axis is going to be the normal axis, which is basically for every surface, 90-degree angle axis. And now all of the sticks are rotating in a clean way. Let's hide the loft so that it's not in the way. There we go. And you can see the elements, they are intersecting like crazy here, but they are at least being rotated in a way of how I want them to be rotated, I think. Let's see what happens if we change from V to U for the A input here. That's also nice, but this is like 90-degree angle from what I want, so back to V. Yeah, this is nicer. Okay, so we get this, then we do ungroup. And from here on out, we can just kind of, yeah, it's the same output as our frame and our glass. You know, with a few extra steps. So how do we work with this? Well, we can now design our stick. Right? Instead of using something like this, let's actually do some 3D modeling. We're almost there. We're almost there. Let's clear it. Clear values here so that it's not updating every time we try to do something. Let's just think. So I can make this smaller or thinner, scale 1D. Let's make this into a plate. 25? Something like that? Yeah, I think 25 should do the trick. And let's make it much shorter. Maybe not the midline, but something like this. I'm not using a precise... I'm not having it very precise here, but you know, just precise enough for it to kind of look real. Then let's make an extrusion from this surface. So I'm selecting surfaces by holding Control Shift, by the way, Control Shift, and I'm gonna make an extrusion right here, like so. And I'm thinking of, maybe let's make 2 extrusions. One, and then one more. Like that. Hell yeah. Okay, and then I can take this surface right here and kind of move it out to make this a little bit of a thicker boy. Now when I think about it, actually let's lock everything except this. when I think about it, this should be a little bit back in, because I want the thickest area to be somewhere somewhere here, right? It just makes sense for it to be there. Something like this. So we initially are making a banana here, which is fine. Which is fine. Then let's select this area. Again, Control Shift, very useful modeling aid. Like that. Let's extrude it here. Let's make a little bit of a cross type of a situation going on. Let's take this edge, move it in here. Perhaps this lifts up by like 50? Could be a little bit more aggressive, I think. But for now, let's keep it at 50. I think that's fine. And maybe this one moves up by 100. A little bit flat, isn't it? Let's be more drastic. More, 150, so 250 in total. Yeah, something like that. That seems better. That seems to be good. Then let's take this edge and this edge and this edge. Dupe edge. Join them up. Let's see. So I have these edges. I kind of want to extrude them out like so. So again, I'm using the extrude button. Extrude them out like so. Perhaps this point right here moves back in to here. And then this edge enter vertical enter moves from here to here, so that it's all basically flat. And then this point moves down, something like that. Maybe it keeps going down until it reaches the corner there. Yeah, seems like that would do the trick. And we just extrude it backwards by 25. Oh yeah, and I don't need that anymore. And all of these, we just use like Boolean union. And merge all coplanar faces to merge it all up and clean it up as well. So now it's nice, tidy, and clean. Is there anything else I want to do? A little bit on the thick side, so perhaps this whole area right here can kind of chill a bit. A little bit more of a banana type of a situation, and maybe this can be a bit more pointy. Like that. This as well. Like that. Yeah, so it's basically like a plate that anchors into this H shape, and it can rotate around some sort of a, a hidden mechanism. Let's reference it in. Let's see how stylistically how it looks. Set 1, brep. Rhino. Looks just fine. A few intersections on the corners, that is natural, that is expected to happen. Some big boys there, that's fine. But no major intersections, so everything seems to be quite nice, quite well behaved. The geometry is well behaved. Let's increase the resolution. My favorite part. 20. Oh yeah, and before you do that, definitely save your files, or else you're gonna cry in the corner. So save, file save. Where's my Revit? Hello, Revit. Trying to find, yeah, there we go. Save that. Okay, so now even if it crashes, it's not gonna be a disaster. With shaded preview, I'm going to just look at how 20 by 20 looks like. I think by the end of it, we will do like 20 by 30 just to make it a bit more visually interesting. Yeah, 20 by 20 seems to be quite nice. Okay, so that we have that. Let's stop the preview there. And let's do 20 by 30, or do we... Give me a second, I'm thinking. So that's the stick part. No, let's finalize it here, and next video is going to be all about just cleaning everything up and making everything, you know, kind of final. So here we have our 3 different B-reps that are used. The domain box needs to be somewhere here, more easily accessible. By the way, if you increase the height of the domain box, the height of these panels will also, well, it will not increase, it will actually squish down. Because now we're remapping to a very high, like tenfold actually. So if I were to do 200 instead of 100, see how this will become much calmer, much less punk rock. Let's wait for it to calculate actually. There you go. See, much less punk rock, which is fine. Looks just fine. Yeah, I think with the shading in place, it's gonna look great. So we have that. What else? What else? Kinda want to go back in here and let me just check. We're sticking out quite a bit. No, let's keep it. Sorry about that. Let's keep it. 20 by 20, let's do 20 by, or let's do 5 by 5. And let's just work on the exporting portion, because, you know, we need to actually add it to, from Grasshopper into Revit. So let's go to Revit. Yeah. Revit direct shape, add geometry, direct shape. Bam. And for glass, the ungrouped glass rather, don't forget to right click on the ungroup output and choose to flatten so that everything is in one big happy list. And then geometry goes into, definitely not the name. I'm stupid. The name is glazing panels. Glazing panels, for instance, that's the name. The category, you can either go to the direct shape categories right here and choose a category, or if you know that you will not be changing it, you can right click and from here you can choose a category that you want. So I will actually, just to keep things clear, I will go to direct shape categories and find glazing. It should be, wait, no, it's not glazing. Revit uses something else. Curtain wall, curtain panels. There we go. I'm gonna use curtain panels. That goes into the category. Then for geometry, I'm using, of course, the glass. It immediately gets imported right here. And then for the material, I will just use a color swatch real quick. The color swatch is going to be a little bit cyan and a little bit transparent. So half transparency, cyan color. And I will be using under material here in the Revit tab, convert material, like so. connected there. So, you know, it's a little bit glass-like. Nothing too fancy. Then, let's do it again. Direct shape, add direct shape, add geometry, direct shape. The panels are gonna be our geometry, or sorry, the framing. Don't forget to right click and choose to flatten the output. It helps with the data management later on. Then in the panel, I'm gonna say glazing. Come on. Frame. Like that. For categories, oops, that was my mistake. For categories, I'm going to just copy this, paste it here. And I'll say curtain wall mullions. That's gonna be my, like these frames are gonna be considered curtain wall mullions. This is inside out. We will address this in just a second. Actually, I should address this now because I know exactly what's wrong. So, bugs that you might encounter. Bug number 1. Notice how this geometry, well, the intersection happens because we're using such a low resolution while we're exporting, but the main thing is the inside out look. This is not something that we want, right? And the reason for this inside out look is because if I were to bake out the loft, the initial loft that we're using, insert, and if I were to just look at it in a shaded view and go to display, color back faces, and color the back face red, you can see that my surface that I get after the loft is actually inside out. This is the back face and this is the front face. So the way we mitigate that is by using a negative value for our offsets for the surface box. This is like it technically works, but apparently it doesn't. Apparently Revit just completely freaks out and gives you an inverse geometry preview after you bake it out. So we can't do that. So what do we do? Well, we will be using a tool that's called Flip Surface. Oh, it's just Flip, sorry. A tool that's called Flip for this, and we will be routing the loft through this flip, and then everything that goes into the loft, we should do it this way, everything that goes into went into the loft should go into the flip. And give me 1 second because I need to double check if there are absolutely zero places where this is going to break. Yes, there are. Not a single place. It's gonna work. It's gonna work. So, how do you reconnect all of these wires from loft into flip? Control, Shift, click, and drag it from here to here. And then loft goes into the flip, gets recalculated. See, immediately shading fixes itself. One last thing, the negative value, that should be not a negative anymore, that should be a positive value. So I'm deleting the node here, and I'm gonna connect, wait for it to recalculate. Please don't crash. It's crashing, isn't it? We were so close. So damn close. Okay. 1 second. Okay, I've rebuilt it. We're back. So, where were we? Where the hell were we? Right, it crashed when I changed when I deleted the negative value here, so now it is indeed gone. And I've just replaced it with 1000, and you can see that the shading issue persists. It's still there, which means that it actually, even though we changed it here, it probably was not the culprit, or it was part of the problem, but it was not the overall problem. The problem is still the UVs, or the surfaces, the normals being flipped off the NURBS geometry, which is very weird because the NURBS geometry that we have here is closed. So there's no way that the normals can be flipped, but well, they are. So one way of how we can force this to actually work is wherever our B-reps get ungrouped, I can say, let's deconstruct them. Right, so we get all of the faces of these B-reps, and then I can just simply force them into being grouped up again. I think. We'll see. Join. B-rep join. There we go. So now they are all basically it's like explode and join, right? We right click, we flatten, and then we connect it to our geometry direct shape input here, and lo and behold, it actually gets yeah, it just gets solved. So that's weird, but hey, as long as we can solve it, I'm happy. We have this. Last one, our panels, our elements. We're doing exactly the same thing. Direct shape, add geometry direct shape. The name is going to be sticks. Let's be consistent. Since we're naming them sticks, we'll continue naming them sticks. Let's flatten this. Check if the shading is right. And the shading is not right. Again. So let's deconstruct. This is weird. That's weird that we need to do this, but you know, it only costs us like 0.4 seconds, so it's not that big of a deal. There we go. Oh, this is even less. This is 0.1 seconds. Flatten that. Join it up. And now the shading is correct here. Nice. This bad boy goes right into the panel though, which is weird. Why? Oh, right. It's because of the resolution. It's just the resolution is way too low, so it doesn't catch the correct angle for its angle of rotation. That is okay. That is actually okay to have. Like that, and oh yeah, category. Forgot the category. So for the category, we will, let's borrow this. Like that, and let's just choose, you know, what kind of what are these? I could say that these are curtain wall mullions as well. They could be something else. I'll let you decide. I'll say that these are indeed curtain wall mullions as well. So we have 1, 2, and 3 parts of the facade right here that are automatically generated. Save, Save everything. Great. And let's increase those values. So I will use, what do I want to use? What do we want to use? I remember 2020 was very heavy. So let's do 2030. Because 2030 I think is going to be on the edge of not being used, like of us not being able to use it properly. While this is calculating, I'll talk a little bit. First of all, files available, Patreon supporters, blah blah blah, link in the video description, you know the drill. Second of all, please subscribe to the channel. I will be uploading much more of this type of a content, so make sure that you're subscribed to actually find that content. We will be taking a look at how does Revit work with sub-D modeling, for instance. So if you have some sort of very complex sub-D form, 20 by 30, and this is going to take a while. So if you have some sort of a very complex sub-D shape, you know, degree 3 curvature, everything is kind of fancy and so on, will Revit just scream and crash and burn, or will it be able to handle sub-D, and will it be able to produce proper sections, proper plans, and so on of the sub-D shape? We will be investigating that deeply. Also for this channel, I have a plan of doing more of these kind of complex facade systems that you can only achieve with Grasshopper, and not just that, but also more complex like building typologies as well. So a bunch of experimental stuff that will most likely break Revit most of the time. We'll see if that will work or not. Come on, dude, come on, just do it. Shall I pause the video? I should probably not pause the video. I can see stuff. Oh, it's there. Oh, it's so clean. Some might say it's too clean. I don't like it. Do I like it? Maybe I do. Maybe it's fine. I will pause the video and I'll play around with the tiling here until I get something that is nice, and then I will unpause the video and show it to you. So 1 second. Okay, I found it. I found a pretty good arrangement of elements. I'm using 30 by 15. So it's all of the panels are a little bit longer, right? Or 2 times longer than their width. And also, where's our Rhino? Rhino, hello, yep. I've changed the positioning of these circles. Remember the spin force? The the tornadoes. So we have one here on this area. We have one just kind of chilling out right here in this area. It has like a small influence over this. And we have one right here at an angle. This seems to be a little bit calmer, a little bit nicer. It's more like dragon scales right now. So that's the preview that we're getting. I think we're done with this tutorial, with this part of the tutorial. This is the Grasshopper file that we have. Again, Patreon. I mean, third time this video. I should stop saying that. Link in the video description. But we have this Rhino, Grasshopper, and the main Revit file. All of it is parametric, meaning that if we changed our construction curves, that we used at the start, you know, the curves that we used for the loft, everything will follow. The floor slabs, the columns, the skin, everything will follow, meaning that, you know, this kind of a model is fully adaptive. Next up, in future video, we still have one part left to do. So in future video, we're going to be working on the sections, as well as we're going to be working on the vertical connections for this. Perhaps a glazing system at the ends, maybe not, depends on how much time we will have, and the surroundings, just to kind of finish things off and call it a day. But yeah, that's gonna be in the future videos. I hope you enjoyed this one, and I'll see you in the next one. Later.